So parallel lines. And on this chart, we have parallel versus skew. Parallel lines, as you may know, look like this. It's when two lines go in the same direction forever and ever. They never intersect. There's also a little symbol that often goes on parallel lines. It's this little arrow right here. And if each line has a matching arrow, that means that those two lines are parallel. And so parallel lines, same direction. They never intersect. And they are coplanar. Okay, that's pretty easy. We know what parallel lines are. You've been seeing that probably since elementary school. Skew lines is maybe something new. Skew lines. Skew lines. It's hard to draw on paper. Like I started with a drawing here, but skew lines is a little bit more difficult to draw. With skew lines, they never intersect, skew lines, but they don't always go in the same direction. Are you kidding me? Don't they know I'm trying to teach? Hello? Good. Sure. Alex is for you. Did you clean your room this morning? Your bedroom? Your mom's house? Okay, skew lines never intersect, but they don't always go in the same direction. So how does that work? I'm going to give you kind of like a visual. Okay, so one line might be going like this way forever and ever, and then you have another line up on a different plane that goes forever like this. So they never intersect, but they aren't going in the same direction either. So they're just like lines on different planes that never run into each other. If this line is like a little bit slanted like this, it could, I guess it still wouldn't intersect. So as long as they're on different planes, they'll never intersect, and those are called skew lines. So they are non-coplanar, they aren't on the same plane. They don't intersect. And an example would be like highway overpasses. They cross, but you aren't running into the other cars. Okay, so on these, we're going to look at examples of parallel lines on like a 3D shape and also skew lines on a 3D shape. So an example over here might be segment A is parallel to DC, or the line that includes AB is parallel to DC. There's actually a symbol for parallel, so we can say that AB, instead of writing out parallel, we can use this symbol. AB is parallel to DC. And there's lots of parallel lines in this shape. Just kind of erasing my marks. You could also say that line CH is parallel to line BG. So you could say BG, oh, where am I gonna write? Trying to make room. CH is parallel to BG. And I could be writing parallel lines all day, but those are two examples. And then over here, we're going to look at skew lines. What skew lines do we have in this shape? Of course, there's actually a lot. Let me point some out. Maybe this line, EF, and then BG. These are two lines. They'll never intersect. They aren't going in the same direction. They're just skew. So EF and BG are skew. Or skew lines if you want to be technical. Okay, these boxes, nothing goes in them. And then over here, we're going to look at parallel planes. Parallel planes. So parallel planes, planes that do not intersect. Just like with parallel lines, they just run parallel to each other. So for example, right here, we have this plane. So the top part and the bottom part, those would be parallel planes. So we could say plane. Remember, when you name a plane, you only use 3 points. So we could say plane ABC and plane EFG are parallel. Okay, from here we're going to answer questions based on this vocabulary. We're going to look at this rectangular prism. It says, think of each segment in the diagram as part of a line. Which line or planes appear to fit the description? So we're going to look at these descriptions and identify them on this rectangular prism. Lines parallel to AB. So here is AB, and we're looking for lines parallel to that. There's actually 3 more that are parallel to that. So we could say that line DC, HG, and EF. Does that make sense? Pretty simple. Then it says a lines perpendicular to BF. So BF right here. Lines perpendicular to that would like intersect and make a 90-degree angle. So the lines that would do that would be right here. Let's see, that was B, right? So maybe BC, AB, also FG down here, and EF. Next. Yes, if this seems simple, just let it be simple. Then line skew to CD and containing point E. Okay, so CD is right here. We need a line skew to that that'll never intersect and is on a different plane. Containing point E, that would be right here, EH. Actually, there's another one as well. So EH would definitely be skewed to that line. So would EA. It would not intersect because this one is behind and this one is in front, so EA would also never intersect. And then number 4, perpendicular planes. That's something that didn't come up in the vocabulary, but I think you can use what you know about perpendicular and plane to figure that out. ABE. So that's this plane right here, the one in front. A plane perpendicular to that, so that intersects at a 90-degree angle, would be this top plane. So plane ADC. Actually, there's a lot of planes. There's this one also intersects and is perpendicular to that, so maybe BCG. This one over here, ADE. And the bottom one, EFG. And last but not least, planes parallel to ABC. ABC is the top plane. The plane that's parallel to that would be the bottom plane. Plane EHG. And it doesn't matter which 3 points you use to name the bottom plane, just choose 3 points. Okay, next. Okay, over here, this is like the most important part of the lesson is these terms, or of the chapter actually, is these terms right here. These terms you'll see over and over in geometry, and it's an important section of geometry. We are angle pairs formed by a transversal. So often, like a lot in geometry, you'll see parallel lines, and then you'll see what's called a transversal that intersects those two parallel lines. So these two lines are parallel, and then you have a transversal. What happens is because of this setup, you have a bunch of angle pairs that are the same measure. So just kind of going over the concept, for example, this angle and this angle right here have the same measure. So you can use this relationship to find angle measure, and that's what we're going to be doing throughout this the next couple lessons. Tomorrow's activity will be practicing the vocabulary. So for example, these two angles are called corresponding angles. So tomorrow we're going to be practicing the vocabulary that I'm listing right here. So take it in, see if you can figure out a lot of the vocabulary today because it'll make tomorrow easier, but just know we're also practicing it tomorrow. So the first term is transversal. A transversal is a line that intersects two coplanar lines at two different points. Like I said, if these are parallel lines, the transversal is the one that intersects right here. Now you'll notice over here, the lines aren't parallel, but we're getting there. So today we're practicing with lines that aren't parallel, and then tomorrow we'll talk about the relationship with the parallel, or not tomorrow, on Monday. But today we're just focusing on the relationship between the angles. So you have these two lines, and then the transversal is this one that intersects both lines. Okay, next it says blank lie on the same side of the transversal on the same side of the lines. This is corresponding angles, and I'll show you what this looks like. Corresponding angles. Corresponding angles, when you have two parallel lines, are equal in measure. There are 4 different pairs of corresponding angles, though. So I mentioned in this drawing it's this and this. So here it would be this angle and this angle. So angle 1 and angle 5 are corresponding angles. Then you also have 3 and 7. Angle 3 and angle 7 are corresponding. And then you have 2 and 6 are corresponding, and 4 and 8. So if you have the two lines cut by a transversal, I showed you the example where they're right here, but they could also be just like right here. So these are corresponding as well. And again, we're practicing this tomorrow as well. Okay, alternate interior angles. Alternate interior angles, by definition, non-adjacent angles that lie on opposite sides of the transversal. Actually, you know what? Definitions, they boggle my mind because I don't know how you could possibly visualize that in your head. But look at the words. Alternate means alternating sides, right? So if we're looking at parallel lines, alternate is alternate sides of the transversal. Interior means inside the parallel lines. So when we talk about alternate interior, we're talking about alternate sides of the transversal and on the interior of the parallel lines. So alternate sides on the interior. So this angle and this angle. It can also be this angle here and this angle. Those are alternate interior. Then for the next one, we have alternate exterior. Alternate exterior angles. Okay, so looking at the way these words are, alternate is alternating sides. Exterior would be on the outside. So the outside of the parallel lines and alternating sides. So here would be one angle, and then here would be the pair over here. These are alternate exterior. And so here I have this one and this one. It would also be this angle and this angle are alternate exterior. And where we're headed with this, like come Monday, is we're going to use these pairs to figure out angle measure. So alternate exterior angles have the same measure. So then you could, if you knew this angle measure, you could figure out this one because it would be the same. And then the last one is consecutive interior angles. Consecutive means like on the same side, right next to each other. And interior is on the inside of the parallel lines. So here's our parallel lines. Consecutive are on like right next to each other on the interior. So it would be this angle and this angle are consecutive interior. And so would on the other side, you have this angle and this angle. Those angles, again, not something that you need to know right now, but on Monday we're going to focus on those angles are supplementary, the consecutive interior. So then we can use that to solve for angle measure as well. Okay, so here we're going to classify angles. Here is a drawing right here. We have a line right here and a line right here, and then this here is our transversal. So this one's kind of sideways from the other ones that we've seen, but you know what? Sometimes they put it sideways. So we're looking at angle 1 and 7. They are alternating sides on the exterior of these two lines. So 1 and 7 are alternate exterior angles. Eight and 3 are on the same side. They are on the interior of the two lines, so that is consecutive interior angles. Then 5 and 6. There's a pair that we didn't discuss up here. 5 and 6 are just a linear pair. They're two angles that form a straight line. So 5 and 6 are linear pair. Four and 2, these are vertical angles. 8 and 2 are alternate interior. They're inside these two lines. Alternate interior angles. And then 7 and 3 are corresponding angles. Okay.